Today we will discuss the LCD cell manufacturing process for TN and STN. That is not a TFT LCD, it's just a TN and STN. And first, we will purchase the glass with ITO. You can see the thin layer of ITO is on the top of the glass. And it is dirty, and we need to wash it, clean it. Normally, we use a brush wash with a detergent and rinse it into that with a DI water. That is a very it is iron-free water to clean the glass. Then we use a photoresist coating. With use a roller coating on it, and then we put a black mask on the top and use a UV light to expose it. Actually, this process is pretty much like the old black and white film. That is a camera that is exposed process, and the black mask, the price can be quite different. The lower cost is made by film, so that it can cost $50 to $100. And if it's a higher resolution, so we can use the iron mask that will be around $1,000. And if it's a very high resolution, used for COG process or for our graphic display, so we can use a chromium mask. That is a very stable and a fine gap in the photo mask, and it can cost $3,000 or $4,000. And as we expose it, so we will develop an etching, and we will first get rid of the photoresist that is already exposed under the UV. So this is a solvent that is resolved, just dissolved the part of the photoresist. So without exposed to UV, so the photoresist still keeps there. And then we use acid to etch the ITO. So in that case, we can form the pattern on the LCD glass. And then we use a polyimide coating, to coat the glass. So why use a polyimide? Because the liquid crystal need to have alignment to have same orientation. So in that case, we need to have some material, polymer material to orientation of the liquid crystal molecules. And polyimide is the most stable material there. And first we coat it with a polyimide, and then we rubbing with fiber. So in that case, can have some traces on the on the polyimide. So in that case, the liquid crystal molecular can lay in the traces that make the liquid crystal molecular orientation. Then we need to print in one of the glass of the electrode paste. So in that case, that will make the top glass that is conducting with the bottom glass. So in that case, electrode can just put on one glass, not both glass. And also we will print the cell. So in that case, that will be make the round cell, and then the liquid crystal fluid will not flow out. And then we will spray spacer. Spacer is some kind of plastic particles, with a very uniform diameter. So in that case, we can keep two glasses with the very uniform gap. And then we will put two glasses. You can see the top glass that is with with around the cell, and the the, the bottom glass that is with conductor here. So in that case, we assembled together. Because this all these cells are epoxy, so we need to have hot, press together at the same time to cure the epoxy to make this bonded two glasses very strong, so it will not fall apart of the two glasses. And go to the next page. Okay, so we have the cell already built. Then, because we built mother glass, all the cell in the mother glass, so we will use scribe it to make it into the small pieces. After scribe it, and then we will break it into the small pieces. You can see there's a 1, 2, 3 LCD cell there. And then this is a vacuum chamber. We will put the opening of the cell deep into the liquid crystal material, and first vacuum it, and then dip it, and then put pressure it, and so the liquid crystal will gradually fill into the fill into the cell. And then, because there is an opening here, we need to use some glue to glue it. Just to prevent the liquid crystal fluid, to escape from the cell. And then, there is a 3 cell here, so we continue to break it into the small pieces. And then we will put the polarizer there, on both sides. And then we will have visual and electric test, for 100%. You can see this is a visual test, this is the electric test, and then we package it and ship. Okay, hopefully this is understandable procedure.